Good morning, everyone. My name is Nikki. I am from Polytechnic. So, till now we have discussed about the um, introduction to highway engineer, and that we have seen also alignment, highway alignment, and the uh, important points where the alignment should go, obligatory points. So, we have already seen that the points to which the alignment should pass through, and the alignment should have the shortest route or easiest route, where we have two terminal points, uh, and town to be served, and railway crossing and mountain, where we have to take a alignment, different alignment, deviation, you can say deviation from the alignment route, straight alignment route. Where there is any two terminal points are connected, it is necessary to deviate from the shortest route. So if it is any important terminal points are coming, then we have to deviate the alignment, and shortest routes, and we can go for the those terminal points and should be connected. So when the alignment should pass through the intermediate point, it can change also the shortest route. So whenever the alignment passes through the level crossing of railway line, it is necessary to deviate the alignment from the right position of the level crossing. So then also we have to deviate, and the obligatory points through which a road should not pass also make it to deviate from the proposed shortest line. So these are the points where the shortest alignment can deviate. Main purpose is to make the easy and shortest alignment we have to do. So that's the points where the deviation get the chances. So the obligatory points which we avoided are religious places like temples, and also and church, and very costly structures where there are, and graveyards. We should deviate those um, structures. So we have to deviate those places. So then only the alignment can get deviator from the phone. So any lake out there, so it should be avoided, as a straight alignment is to be changed. So the lake is there, where there is a cost of that bridge or a culvert is also important. So for that also we have to where the um, to construct that, um, we have to see the at cost of the whole structure, then only we can go, no, not for the short route, we can go for the another route also, deviation is. So today we are going to discuss about the engineering survey. So in engineering survey we have to study about the map study, recognize survey, survey, preliminary survey, final location, and the detailed survey. So, what do you mean by map study? Map study is nothing but the already topographical map is done with the help of the survey. So, find out the possible routes of the route. Like you can say, you can take the India map, topographical map already done in the survey of India. It will be available. So, take that map and do the possible routes. So, in that you have to see how much. Chances of getting of we have discussed. So shortest route we have seen. So shortest route, is it possible, or is there any obligation points, obligatory points, are there are any control points to deviate the short route? We have to see after locating the route on the map, then we have to go to the field, and we have to see the what's the points there uh, to deviate. So these are the, we can follow the information. What are the information we get on the topographical map is nothing but alignment, avoiding the valley, ponds and the lakes. So we cannot change. They are available from a long period. They are, you can say, valley, ponds, and lakes. And next comes to when the road has to carry a row of hills. So row of hills are there. So that can also cannot also deviate. So that also we have to see. So alignment, avoiding the valley, ponds, and lakes. When the road has to carry a row of hills, mountains, pass, so maybe suitable alternative. So we have to avoid that also, and also approximate location of the bridge site. So if there is a bridge is there, so which is the alternate route of connecting that bridge and we have to go. So that is also we can show the topographic map. So this is about the topographic map. So in India, with the 15 to 30 meters control intervals, we have the map set. Topographic map. So in the topographic, we have the interval of 15 or 30 meters contour intervals. So the main features here we have seen the river valley and hills we can find out. So those are we cannot move those. So they are by nature itself. So if there is any roots or if there is any hills or any valley in our alignment, so we have to see in the map itself deviation. And so if the possible can be located on the map from the available on the map, so we can avoid that one. Or when the we have any bridge, okay, or location of the bridge for crossing rivers we have to decide. And we have to decide the road approximately between two consecutive contours between gradient also within the allowable limits. So we have to see. So I have already said that by the contours we can see the gradient. So gradient is also important. We can either we are going in the ruling gradient or not. We have to see allowable limits, and also we have to see the scale of the contour. Possible routes may be drawn on the map itself. So we can see the possible routes in the map, so that we can find in the maps itself 3 4 alternatives in the maps itself. In the within the scale we have to draw, so that we can know the routes by the map study itself. Next comes to recognize survey. Recognize survey is a simple instrument, a simple survey. It is done by the survey instruments, minor instruments. So following the information obtained from the recognizer. He- In the map, we have identified the valley, pond, and lakes, and other features that were not present in the topographical map. So then we have to go a number of cross drainage structures, high flood level, head, and a natural ground level. So if we can see in the contour map, rather than that, we have to go and we have to see the visit the field. Then we can get to know the nature of the ground level, what is it. So next comes to values of gradient, the length of the gradient and the radius of the circular curve. Any curves are there, so how much radius we have to take to that curve. And soil type along the routes from field identification test and observation of the geological features. So here soil type is also most important. So soil type we have to see the bearing capacity. And so the bearing capacity of different soils have different um, uh, different capacity. So different capacity means the if it having less capacity means if it is clay doesn't have the the, doesn't have uh, it's a mean to say it will change according to the um, presence of moisture in it. So if the water is there in the clay content, then it will behave one its behavior is different from without water in the moisture content in the clay. So the property will changes, so that will affect the soil road also. So that alignment where we are going, that is also important. The soil type, if it is loamy soil or it is any alluvial soil or it's having any red soil, we have to say so better we will prefer red soil for the road type. So soil type along the routes from the field identification. So how we can say that, how can we can see that capacity by testing in the laboratory itself. So next comes to sources of construction materials. So here we are have to see the sources of the materials also. The road means it will go through a for a longer distance. So the materials are available or not, we have to see that also, very important to that. So in the we have to see the sophisticated survey instruments are used during the preliminary survey. So objective of the preliminary survey are to collect the physical information and details of topography, drainage, and soil. So in the preliminary survey, what we have will find the drainage and the soil capacity you will collect. So in the map study, we have seen the located the where the route is possible and the on the map, whether it have any valleys or hills or any water bodies are there, like that we have located on the map. In the preliminary survey, we are uh, gathering the data of the soil and also the drainage capacity of the soil. So that is we are doing in the preliminary survey. So to compare the different proposal in view of the required good alignment, so it is necessary to estimate the earthwork also. So we have to if we are going to propose a alignment, so this is the final, like that we are going to propose means, so then they have to estimate the earthwork. So rough estimation or abstract estimation should be done from the can be done with the preliminary survey, so to find us the best alignment. Next, in the preliminary survey, there are two approaches are there. You can say conventional approach and the modern rapid approach. So, what is conventional approach? So, the procedure of the conventional approach are listed below. Where it is traverse. So the traverse is run from the starting point to the end point by setting out the so compass traverse, or you can say. So how can we find it? When setting at a one point and it is like bending to the same point, then it is a traverse. Both the primary and the secondary, open traverse and the closed traverse, both are then. So next comes to we have to do twice, primary trials and the secondary trials. Next comes to leveling work. So instruments what we are going to use leveling. The leveling work is carried out along the center line of the proposed road. The leveling work is used to estimate the volume of earthwork. So in the leveling work we can estimate the quantity of earthwork. Next comes to topographical features. All geographical and man-made features are surveyed and plotted, which are along the travels and for a certain width on either side. So width of alignment is for if we are laying for the single lane metric, the 3.5 meters should be there. So it will we have to check the traverse along the traverse also, not only the along longitudinal, we have to check the traverse also at a certain intervals. Next comes to drainage studies and hydrological data. So the number of cross drainage structures are estimated during the preliminary survey. So in the preliminary survey, we have to expect the how much of cross drainage works are to be going to get. throughout the alignment. So that also we have to do that one. Next comes to soil survey. So the soil survey is conducted in working out the details of earthwork, slope and stability of the materials. So here we have to see the estimation of earthwork, and also we have to see the slope, so how much gradient we have to keep, and also the stability of the material. So which type of materials means how much size we have to use as a sub base materials. So here that also we have to see, and also subsoil and surface drainage. So how much capacity of they to hold the to pass the rain water from the road to the surface of the besides to the roads. So drainage capacity also. So if the water holding capacity is there to the soil when the rain is there means it will erode the road. So that capacity also we have to check it whether how much time it will take to drain off the water on the surface. So requirement and the type of payment. So if this capacity is there. So which type of road, either a flexible road or any CC road, or which type of road we have to lay to that surface we have to see. Next comes to material survey. The location of construction materials need to be known. So the materials need to be um, the construction materials need to be known which type of materials we have to use. That is also we have to know. Construction materials going to say um, uh, that we already said no, that aggregate size of seed, which type of materials we have to use. Next comes to traffic survey regarding the number of lanes and roadway width and pavement design need to be decided at here in the preliminary survey. So that will say by the traffic survey how much width of the lane we have to lay. Next comes to determination of the final center line. So after the completion of the above steps and calculating the amount of the earthwork, the final center line is determined in the preliminary survey. So in the preliminary survey, we are going to see all this. Next comes to modern rapid approach. So how we So in the modern and rapid approach means conventional and modern type is there. Conventional by manually we are going and we are taking the all the details of the soil and all the topographical conditions of the field at that place. But in the modern survey, how we will taking the aerial photographic with the required lateral and longitudinal overlap. So by sending the for aerial uh, instrument, they if we will take a picture of that location of a field, so that it will examined under the stereoscope, and control points are selected from the establishments of the traverse. So here what we will they see, if we will collect the data with an instrument known as stereoscope. There we can see the control points of the traverse there. So by taking a picture of them, by keeping that data um, into a system, there we will get the control points of that the field itself. Next, the spot levels and the contour lines may be obtained from the stereo pair observation. So photo interception method is used to grab the information on the geological features, soil condition, drainage requirements, etc. So without um, without going to that field, we can grab the picture and we can get all the geological features of the soil conditions there there itself. So with this instrument known as stereo, so that instrument will capture the data. That the data have different chip that it will convert it into a system, means that already have feeder data will be there, so that data about the geological conditions and about the drainage conditions, so that attribute data what is there in what will be the in the data itself, we can get it by giving that location itself. So this instrument is just like we can see the GPS or GIS. If you know the instrument, we already seen in the first year survey. That we can we can know about the stereo instrument. Advanced survey also we can get this instrument in advanced survey. Next comes to final location. So here it is more easy, and in the modern rapid survey we capture the picture by aerial photograph, and we have get the information without it easy. So here final location and the detailed survey. This is the final. First, we have done the map. Afterwards, we done about the preliminary survey. Preliminary survey, we have discussed about the conventional survey and the rapid survey. And next, we are going to discuss the final location and the detailed survey. So, in the location. So the center line of the road, which is to be finalized in the preliminary survey, is then located in the field by establishing the center line. So major and minor control points are then established on the ground, and the central pegs are driven, checking the geometric design criteria. If necessary, the modification of the final location can be altered. So there we have fixed one center line. So that was finalized in the preliminary survey. So that should be located in the field. How we will by establishing the center line in the field. We can see in the road it's a one white mark will be there, that can be called that is the center line of that road. So that center line it should be marked in there. Major and minor control points are then established on the ground, and the central pegs are given. So by taking some benchmark, there we are doing the we are finding the levels itself. So we are by checking the geometric conditions of the design what we have given, that on that if there is if there is a um, any problem, the modification of final location can be altered there uh, in the location itself. That is about the final location, how we will see. So till now we have seen about the map survey and the recognized survey. So a preliminary survey you can say. So in the recognized and the So in the map study, we have fixed the routes of different routes by seeing the topographic map, and there we have find it the alignment. There we have find the any valleys or ponds are there. There we have find it, and we have find it the ponds or hills are there. So in the we will find the three or four any all three two, three alternate routes at the um, map itself, topographic map. Next comes to recognize survey. So before going to the preliminary survey, we have to recognize. So how we will recognize by taking the rapid and the rough survey. So in the recognized survey, what we are doing the rough survey. So in the rough survey, we have seen the physical characteristics of the area by inspecting the uh, by inspecting the proposed route. So we have proposed two or three routes. So that two routes are we have to go and we have to see in the field how it will be there. So in the by using the instruments there we have seen we have to use the we have to do the survey. So that survey instruments mostly apnea levels are used or compass we have to use and the barometers we have to use. So, with the help of the apnea level and the barometer and the pocket compass, we can get the level at those points. Also, the survey, the will get the information available which is not available in the map. So here we are seeing the field conditions in the recognized we are doing the survey. So there we are seeing the field condition of that. So after the main object of the recognition survey is to study the feasibility or practical of the proposed route. So we are seeing the estimation part. So the feasibility. So which estimation of the proposed route which is going to be proposed. That route should have estimation we are seeing, and we are seeing any valleys and points are there, or any permanent structures which are going to obstruct about the alignment. Next, we are going to see the how many cross drainage works are to be getting in it and maximum flood level. So if it is the low lying area, so what is the maximum flood level it is getting. So by that only we can decide how much height of cross drainage work we have to construct, and we are should see the natural groundwater level also. So the soil capacity of that one. So how much water can are there. So after rain also how much water it is storing that soil we have to see. And also if there is no chance then we have to go um, probable routes either. So we can if the maximum flood level and that water capacity of the ground is more, then we um, have to spend a lot of money on that. So cost will be more. So instead of that one, we have to deviate to that road to another proposed route. So next we have to identify the type of soil particle. So from the field for field test. So by observing the geological features only, then also we can decide the road. And by all this gathering, what we have to draft a report. So the drafted report for a nature of the soil and availability of the materials we have to see, and transportation facilities also we have to see. Any obligatory points are there that also we have to see, and we have to propose a different route for the anticipated. And here we have to see also design, traffic design also we have to consider. So all this will be done in the recognized survey. So next comes to we have studied about the preliminary survey. In the preliminary survey are going to uh, all the on the basics of recognize means on the data which are given. We have now itself we have studied about the data which was of the field conditions were recorded in the recognized survey. So that on that recognized survey we are going to do the preliminary survey. So it consists of a detailed survey itself. So and also alternate route any selected in the recognized survey. We have seen that if there is a possibility of getting any alternative because of any obligatory points with that deviation with chances. So that route also we have to know it. So it is done by using the instruments. Here we are using instruments of chain, compass, tape, and theodolite. So we can here we are using the dumping level and the theodolite, chain, and compass. So these are the instruments, chain, tape, and compass are going to be used in the preliminary survey. So in the select here we are selecting the best route of going to which is going to be finalized. So in the preliminary survey, we are proposing that route, and we are whatever the data have collected in the recognized survey, we are seeing the soil conditions and the drainage capacity, and here that we are finalizing the best alignment in the alignment on the based on the different factors. So we at last we are determining the central line. So we have proposed and it's also finalized. So we are finalizing the central line for this route. So the estimation of the approximate quality of the earthwork materials also, approximate quality of the earthwork also materials also, out of the cost, or we have to see the estimation of the earthwork also, and we have to collect any additional information found on the recognized survey. So this is about the additional information, it's there or not, we have to see that. Just the preliminary survey can be carried out by any of the two methods. So in the we have seen that the conventional method and the modern rapid method are there. So conventional method, we have seen all the different uh, methods which are carried in the field equipment taking measurements. So other topographical methods are the other data required to fix up the final alignment. So in the modern survey, by using the modern instruments like aerial method, or by using the stereo photograph method. By that photographic methods, we can interrupt the techniques without going to the field. We can get by capturing the um, photos with means of aerials. We get the data. So these are the two methods that are used for the preliminary method. So additional to this one, the routes recommended in the recognized survey should be accurate for the traverse lines. So the traverse should be open, not the closed. It should be open, and accuracy at least 1 in 3000. So should have the gradient of 1 in 3000, so that accuracy will be more. So the idea of this one is to get the earthwork quantity along the traverse and also the longitudinal section. So along the longitudinal section, we have to get the earthwork, earthwork quantity. So the following information is to be collected from the preliminary survey. So in the topography, in the map survey, we have gathered about the information of the valley, mountains, and the valley and the mountains and the hilly areas and the contours we can see in the map study. And then next we are seeing in the preliminary survey, we have studied in the preliminary survey ground levels. So ground level conditions and any important structures are there, so that we have to deviate that and give the better alternate, and fences and other boundary lines are there or not, we have to see, and any commercial and industrial buildings are there for the route alignment we have to see, and the position of quarries, any mines are there we have to see, and also rail crossings are there or not we have to see, and existing drainage particulars. So any drainage drainage are existing. So that also we have to see, and natural water sources. So um, before the time of the topographic map, might be doesn't have the some features like natural water sources that might be come to after the few years back. So at the time, that also we can see the data in the preliminary survey. And next comes to cultivated area, how much area is cultivated, that is also we have to see, and the soil particles we have to see, all other particles of a site which affect the final position, we have to get all this information in the preliminary survey. After the finalizing it, The final alignment is determined in recognized survey, so it is made straight way. If not final choice of alignment, it should be decided in the preliminary survey. So we have to decide in the preliminary survey only final alignment, so that if any deviations are there, that better and better route have to be given in the preliminary survey. So after that, we have to given as a final location. So in the final location, what we are doing, we are finalizing that whatever the data is there in the preliminary survey, we are finalizing that route as a final and the first located. After that, it is a route as selected, and that route should have the objects. The final location of the objects are to locate on the ground, so the center line should be located on the ground, and it should have the temporary benchmarks. So we have to establish the temporary benchmarks also, and we have to collect the information of mm, preparation of the working rules. So in the final location, what we have the surveyed in the preliminary survey. So we have given the all the levels. By that we have calculated the estimation of the earthwork. So there we have to prepare the drawing also, working drawings also, and we have to given the detailed estimation in the final survey. So in the final survey, what we are doing, we have to give the drawing itself, finalize the drawing, and we have to give the detailed estimation we have to calculate. So the design of the road and pictures also we have to do if there is that. So in the preparing the specifications. So what are the in the estimation, sir, we will get specifications and land equation problems. If there is any land equation problems, that also we have to sort out in the detailed survey. And working out the total cost of the project and the detailed report about the road project. So in the final location, what we are doing, we are detailed all the information, whatever the have done in the preliminary survey. So next comes to final detailed survey. So in the detailed survey, so we are fix the temperate benchmarks and fix the all the underpass the structures and the drainage structures. So along the final center line should be taken with a great important, as these data are required for vertical alignment, earthwork calculations, and drainage details. So a detailed survey is uh, to carried out carried out to be. ఏంటి? ఇది కావాలా నాన్న తీసుకురమ్మని చెప్తాను నా ఫోన్ తీసుకొని వెళ్ళు, నా ఫోన్ తీసుకొని వెళ్ళు, అందులో ఉన్నాయి డేటా అది తీసుకొని రాసుకో. టెక్స్ట్ బుక్ లో రాయాలి, ఇవాళకి అది కానిచ్చేసి బుక్ లో రాసేసి.
అలా అయితే బుక్స్ తెచ్చేటప్పుడు నాకు ఇది హోంవర్క్స్ హోంవర్క్స్ కూడా చేయండి, లేకపోతే క్లాస్ వర్క్స్ తో సహా మొత్తం చేయండి. నేను ఎప్పుడైనా
The detailed benchmarks are fixed at all the underpass structures. So the drainage and drainage structures levels along the final center line should be taken with the great importance, as these data are required for vertical alignment, earthwork calculations, and drainage detailed surveys to be carried out. So enable the drawing. So here we are finalize the drawing, and we are seeing the soil profile. So at a depth till a depth of 1.5 meters to 3 meters below the ground line. So and twice the height of the finished embankment. So in case of high embankment, the data during the detailed survey should be elaborated and completed for the preparation of the plans. So like that, in the final we are deciding the routes, which route is to be finalized we are facing. So the survey operations to be performed for uh, in the final detailed survey, what are the operations we are doing here is the for a road project is the chain and compass are theodolite here we are following. So in the preliminary survey we have seen the level, dumpy level, and the theodolite itself we have seen. So here we are finalizing with the total station or the theodolite here we are using for the fixing of the center lines. So for establishing benchmarks along the route, and we are finalizing the longitudinal sections and the cross sections of the proposed routes, and we are finding the topographic of any queries are there in the site we are seeing, and if there is any curves are there, setting of curves. So how much radius we have to go if there is any curve is to be there. So like that the final data we are doing. So setting of the curves, the location, the center line is to be established in the field should follow a practically as possible as per the uh, line finalized in the preliminary survey. So that is done by the theodolite instrument. So temporary benchmarks is to be established at the interval of 300 meters, and it is based on the Great Econometric Survey benchmark. So that is temporary benchmarks has to be established on the GGS benchmarks, and the cross drainage works are to be taken at 30 meters width of 30 meters intervals. So at every 30 meters width of intervals, we have to take the cross section intervals, and we have to see the all river crossings are there at up to a maximum distance. So center line, we have to survey detailed maximum distance on either side of the center line. So we have to around the width of the road for 30 meters width, we have to decide the uh, 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 for any river crossings that the alignment have to be, because on the hydrological details only the width of the road also we have to see, and we have to see any quarry sites are to be there, and any soil surveys to be carried out not. The depth is generally take at a depth of 1.5 meters to 3 meters below the ground level. So types of horizontal and the vertical curves are to be designed in the approximate highway alignment. So here, all these would be to be considered in the details. So after getting the details survey, the plan should be submitted to the road project. So for the road project, submitted for the government. So for that, the road project is also required. So what are the road project documents are there? So in the road project documents, we already prepared the key plan, index map, preliminary survey details, detailed survey details, longitudinal sections, cross sections, and detailed drawings for bridges and culverts, drawings. So these are the documents where what we are going to submit. So those are the key map we have to submit, index maps we have to submit, and preliminary survey plan we have to give, detailed survey plan we have to give, and their longitudinal sections we have to give, and cross sections, detailed estimations, cost estimations, land plan for quarries, detailed drawings for bridges and culverts, and drawing for buildings and any bungalows are there, and land acquisition problems are there, and a general report we have to give. All these documents have to be given. So those have key map generally have the size of plan is not exceed to 22 by 20 centimeters. So it's the scale should be chosen depends upon the length of the road. So that the length of the that should be given in the paper size of plan size should be 20 by 20, and it should not scale should be also depends upon how much length proposed length is going to be there. So that is also the key map gives, and index maps it gives all the topographical features and existing the natural drainage or drainage lines, all those will be given in the index map. Next comes in the preliminary survey plan. This plan consists of details of various alignments and also information collected to a scale of 1 millimeters to 110 meters. So preliminary survey plan. So in that scale was fixed like that. And in the detailed plans, we will give 1 to 2 meters control intervals and for the plain area and 3 to 6 meters for the hilly area at the contour labs and also the owners of any properties and also the cows, any village boundaries are there, then reduce the levels of bench posts. All the detailed plans were given in the detailed plan. So in the longitudinal sections we will see the vertical scale and the enlarged 10 times to the longitudinal scale. So in the longitudinal sections, we are giving the longitudinal scale of the ground, okay, and the vertical scale we are giving in the longitudinal section. Next comes to detailed cross section. In the detailed cross sections, we are giving the scale of 0.25 meters cross section and any closer intervals. In the detailed cross section, we give the closer intervals and formation levels, and cutting and embankment will be given. And in the detailed drawings for bridges and culverts, so these drawings should give complete information of the bridges, of the plans and sections of the bridges of culverts. So in the next comes drawings for buildings and bungalows. So they will prepare separately and size and scale should be same as the masonry works. So the detailed drawings of these are given separately. So land plans for quarries. So if there is any construction materials are to be acquired for new projects, separate land plans are given to those uh, land quarries. Next, any land acquisition progress. So this they have the property lines, patta numbers, names, all those of areas are to be, all this information are to be gathered. So draft specifications. So the detailed specifications regarding the construction of the roads will be given, and also for the bridges also we have to give the specification in the detail. So any detailed estimations, so detailed estimations are to be prepared for roads, bridges and culverts which are to be proposed. And cost estimates, the cost of entire project is to be prepared and given to the works in the road project. So these are the in the general report what we are giving in the general report we are giving the road project feasibility for the project and the cost of the project is given and how much time is required to complete the project is was given in the general report. So all these the detailed information was given in the document form for the uh, submitted for the uh, submitted for the proposed routes. So next comes to the cross sections for the route in embankment and cross section route for in cutting. Here we can see this is the carriageway. Okay, these are the carriageway, and this is the from these two are the shoulders. The shoulders from the carriageway plus these two shoulders come has the formation width. This is the formation width, and here this is the drainage drainage water is to be get here collected, and this is called as a total has a road margin. So this is the longitudinal trail and this is the slope. So in the slope some berm is there, that berm is useful for uh, uh, has a road has a for a pathway we can use. So this is about embankment. Embankment is all related to the filling. So the root height is little bit filling. Here this is the cutting. So here the height is more, and this is the uh, um, little bit uh, here height is less compared to this one. So this is the cutting he can say. Next comes to highway cross section and embankment. So the road of construction of the hill roads may be partly in cutting and partly in the abutment. So it will intercept the. So why require the cutting and filling? Here we have to see the cross section. So they why it is required. So if it is in the hilly area, so there itself cutting and embankment is more required. So why cutting and embankment? The water, whatever the drain water comes there, that will be collected at catch drains. So that will be diverted into some culverts or any bridges. So there we have to see the cutting in the bridges. Next comes to the spot levels and the contour lines may be uh, captured by the stereo pair photographs. So the photo interruption method is to be grab information from the geographical features. So soil condition, drainage requirements also we have to see. So if we have to see any single line method or two line methods are there. So if the two-line method, a two-line road had to be laid, we have to that road line is the 7 meters width is there. If it is for the single line one, we have to have the 3.75 meters. So that all just seen for the uh, about the uh, cutting and filling of the road. Next comes to the component parts of a road. So the component parts of road are here we are seeing the first one is the subgrade. This is here. This is the subgrade and subbase, and here the road base, and here the binding materials and the bearing hose. All we have seen five different core layers are there. So in the first layer, subgrade is there. So subgrade is the foundation of the road, that it is the lowest and most important component of a road structure. So it should be constructed with a natural surface above the formation level, that the surface is cut down. So already we have seen from the ground level it to be cut it down, so that formation level is to be get strong. From we to say from the formation level we have to cut the surface down, that till the proposed surface. So 1.5 meters or 3 meters we have seen before itself. So that much of depth we have to go for the cutting of the road. So the subgrade, how much thickness given, that thickness has to be laid to that road, so that the proposed subgrade surface has to be there. If natural surface is below the formation level, then the subgrade will be above the ground level. So if it is cutting means we have to cutting, if it is above means we have to fill the surface level. So it should be constructed at least 60 centimeters or 2 feet high from the high HFL. So we have to see surroundings of the high flood level. If flood level, by seeing the flood level, we have to construct above 2 feet high. So the main functions of the subgrade is to bear all the loads which is coming on the top of the layers, just like act as a foundation of the road. So it will transfer the load to the grains which are contact, mean to say that it will transfer the load to the soil. Mm, Soil. Next, these are the materials. So in the what are the materials we are will use? The it is enough to bear the loads, easily accessible and available in the cheap. Okay, whatever the available cheap materials are there, naturally available, that will be laid as a subgrade. So next comes to subbase. So subbase is consists of two types: upper base course and the lower base course. So how it will be subbase will above the subgrade we will construct. So it is no not required, not needed any upgrade if high very high strength. So uh, not needed if subgrade is very high. If it is strength of subgrade is more having the bearing capacity more, having the load capacity more, then there is no need of getting of subbase at that location. If the subgrid is having little capacity, then the subbase have to be laid. So in case of flexible payments, upper and lower base courses are separated having different materials. So for that we are laying the subbase. So in case of rigid payments, only upper base course is provided. So thickness will be vary from 7.5 centimeters. Next comes it prevents the it prevent functions of the subbase. It prevents rise of water or capillary action below the ground surface. So the materials what we are using in this sand, gravel, and the stone for the upper base, and for the lower base we are using locally available materials like rock and stone fragments. So locally available stone materials are used for the lower base course, and it is for the upper base. In the bituminous, what we will use for the flexible loads, we have to lay upper base course and the lower base course. Upper base course we are made should that is made up of sand and gravel, and in the lower base course we are using rock and stone materials. So next comes to road base. So base course. So due to quality of material used in the road base, it is also divided into upper road base and the lower base. It is constructed above the sub base. So what is the main function of that one? To avoid the distortion of wearing hose due to its sufficient density and distortion it is acting as a protection for the wearing hose, so supports the wearing hose. The materials are used in this are high quality load intensity. So in case of lower road base, the materials is also used high loading intensity decreases. So here we are using high quality of load intensity barriers. So next comes to surface. So surface it is the upper most layer of a road section. It can be provided in one or two layers. So it is constructed with usually with two layers with the binder course and the wearing course. In the surface we are using binder course and the wearing course. So wearing course is the touch with the vehicles. So what is the function of the surface course? It will prevent the penetration of water into the pavement. So water will be if the water is on the surface, it should penetrate into the bottom or bottommost layer. It should penetrate easily. Binder course binds the wearing course and also the road base. So the binder course materials acts as a binder material between the um, surface wearing course and also for the base course. So it is acting as a binder material, and wearing course provides a smooth riding and also saves the lower levels from abrasion and weathering edges. So upper level is acting as a protection for the lower levels, so which is protecting from the weathering and abrasion forces. And so materials are used for the surface courses are bituminous materials that for the flexible pavements, and for the rigid pavements we are using the RCC. So this is the here we have seen this is the carriageway, okay, and this is the carriageway or roadway or surface course. This is next comes to the varying course in between the base and surface course. We are seeing the varying course here, and here the subgrade. This is the subgrade here. If the subbase will be put it subbase some pairs will be there or will not be there. Subgrade and the base course, and this is the weighting courses here. So this is about the component parts of a road. So we have seen the different different uh, different studies of survey for the construction of the no for the construction for the laying of the alignment. So and we have studied the component points also. So after getting that, the already we have seen the alignment of a plain road. So the alignment should have the short as possible for the straight roads, and it should avoid the forest area also. And at the work there should be minimum. So that to get the uh, uh, get economical, so it should be easy gradient and also smooth curve should be there. So number of cross drainage works also should be cross drainage works like bridges and culverts should be less. And also we have to avoid the agricultural lands if possible, and any like land acquisition problems also we have will be costly, that should be avoided. And men and material should be available in the nearby areas, and should connect as many as places as possible for the road. So these are the for the plain area. And for the hilly area we have seen that easy gradient should be possible, and it should curve and gradient should not be combined. So if gradient and curve is there, we have to it should not combine, we have to see the alternate route. And deep cuttings and too many hairpin bends also to be avoided in the hilly areas. And shady and snow areas should also be avoided. So where there is more shady, and also where there is a lot of snow is there, those will causes accidents. So those places we have to avoid it at the time of the alignment. So what do you mean by alignment? Here we have seen alignment is nothing but the center line of the highway on the ground. Okay, on the ground, if the center line is laid, that is called as an alignment. So here we have to see the capital lost initially and maintenance cost carefully throughout the life of the road is also main important. So all for depends on all these factors only. We have to see mm, we have to see all the seen all these surveys, map survey and the preliminary survey and the final survey, all this we have seen. Next we have seen about the component parts of the roads. That component parts are subgrade, subbase, and the base course, and the surface courses. All these we have seen. So, in the at last, at the finalizing of the route, these points are to be also be kept in the mind that earthwork should be minimum, and cutting and banking should be balanced where it possible, and the gradient should far as possible as within the permissible ruling gradient. So the ruling gradient should not be more, because if it is more, then there is a chance of accident and the getting skidding of the vehicle. So that should not that make um, uncomfort traveling. So that we have to see the gradient also. And and difficult terrains, and if any maximum gradient have to be kept, that permissible limit gradient should be used, or any exceptional gradients are there, that also we have to see. Minimum gradient should be provided for easy drainage works, because um, uh, for a easy drainage works we have to provide a little gradient for the camber. That gradient is to be seen and we have to provide, and it is preferably to allow the natural ground slope and take the road in embankment height of about 300 millimeters. So we have naturally provided slope we can use at the time of uh, at the time of the survey. We have to see that the high naturally available ground is should like that only, and it can be height up to 300 meters. It is we have to see. So in the marshy areas it should be about 300 above. So the formation from the road survey we can provide till up to the height of 300 above. So the formation line should pass through the predetermined levels and the control points, so that the cross drainage works and railway crossings or navigations, those points we have to see. And we have to see all those points. We have to see all those points. So these are the points we have to remember at the time of the laying of the alignment. and the component parts of the we have already seen the component parts. So that subgrade and subcase, but then subgrade is the foundation, it should be strong and should be more enabled to hold the water more strong, and it should be having the capacity, load carrying capacity is more. And on the surface course, it's a water penetrating should be easily done, because the water percolate, should not stay on the road. If it is the water should be easily should pass from the road, like that we have to decide the surface course.